In Chapter 14, we focus on different types of measurement, including linear measure, area, volume, and things like the Pythagorean theorem. This week, I'd like to get into the first couple sections, which focus on the conversion between different types of units for both linear area and measure, and some of the things to be careful with. But one of the first things I wanted to talk about is the difference between a standardized unit of measure and a non-standardized unit of measure. So a standardized unit of measure is something which is formally defined, like a yard or a foot or a second or a quart or something like that. It's something where, we as humans have agreed upon exactly a particular measure and what it stands for. But one thing that I think is kind of important about standardized unit of measures, there's nothing special about them. They're all human created constructs. Like a meter doesn't mean anything. There's no like natural phenomenon, which is why a meter is what it is. There's just defined by humans and standardized over time so that, when we're measuring things, we as humans know what someone else is talking about. Or if I'm using a ruler, someone else who has a ruler will know exactly, it will be the same type of measurement. It won't be different. So, like, for example, one of the most common types of a standardized measurement is a foot. And if you think about how much a foot is, you can probably imagine, measuring something like that. But you could also think about what we call a non-standardized unit of measure. And like, if you think about how long your foot is, not everybody's feet have the same length. But the idea of what a foot was in its original conception is it's approximately the value of the size of someone's foot. Now, a foot size is not the same as feet, but the standardized unit of measure is that, it's defined to be, 12 inches is another way it's described. And, there's various ways you could measure what a foot is, but feet would be an example of a standard unit of measure. Or similarly, like meters is another standardized unit of measure, which is a little bit, it's very similar to the length of a yard, but in the metric system, it's one of the fundamental types of units. And I want to talk about the metric system a little bit as well, but it's just a different type of unit of measure, but it's also a standard unit. And most of the world uses the metric system. Most of the world does not use what some people call either the imperial system or the U.S. customary system, which is the unit of measure which involves things like feet, yards, pounds, quarts, and so forth. Those types of measurements are not used by the whole world. We think of them as very normal and very common, but some of the rest of the world thinks of them as kind of strange units. And most scientists or college level educated people or beyond pretty much strictly use the metric system for its convenience and for its relationship in our place value system, which is another thing I wanted to talk a little bit about. But an example of a non-standard unit of measure would be something like if you use your foot to measure, for example, how far away, I don't know if you ever played golf and you want to know how far your golf ball is away from the hole. And you kind of trace out foot by foot by foot to see how many steps it takes to get from your position or the golf ball to the hole. Now, unless your foot is exactly 1 foot in length, which mine is actually pretty close, you're not going to be able to measure that very well. And you could have an idea of, how much smaller your foot is than an actual foot to sort of take that into account. But that would be the idea of a non-standard unit of measure, is using your foot to measure something. Or, like, for example, a car length. When you take your driver's test, there's a joke about this in the TV show Big Bang Theory. But Sheldon is very unhappy when he's at the DMV because one of the answers involves staying car lengths behind another car, something like that, which is not something that you can actually measure because cars are of different length. Like, what does a car length mean? And you probably would think of a car length as the length of like your average car. But it's not like something where you know exactly that's this amount and you could convert it from one type of units to another. And another thing I wanted to focus on in this video is what are a lot of the types of standard units and how do we convert between them? And the key to really understanding what units mean is knowing their relationship to other units. And this is something which typically I would want you guys to memorize, but in the case of our exams being online, it's okay if you put some of this information on your cheat sheet, but these are things that you should generally know. the relationships between different types of units. And a lot of times they're categorized based on what they measure. Like what we call linear measures, like the measurement of distance, like how far something is from something else, like inches, feet, yards. And these would all be, the U.S. customary units, and including miles. Whereas in the U.S. system, we use the most typical units we use for weight include ounces, pounds, tons. Capacity is like a measurement of volume, and there is a relationship between volume and length, which is something we're going to talk more about next week, or when we're next time we get into our lecture, which we're not going to cover quite yet. But often it's measured in terms of a three-dimensional component, kind of a relationship towards, well, gallons, ounces, pints, and quarts, and you can kind of understand the general amount based on like a glass. Like for example, if I have a glass of water, how many fluid ounces does this hold? Different from the weight version of ounces, there is a connection there too that I don't want to talk about now. But if this glass were full, it'd be something around 14 ounces. So since it's roughly a half, let's just say half full, it's actually not quite that much, or half empty depending on your philosophical persuasion. You can say, okay, maybe that's 6 ounces or 7 ounces, fluid ounces. And anyways, like a gallon, if your, gallon of milk or a quart, you can kind of judge the size of something based on that in terms of measuring volume. And then getting into a larger scale, I'm not expecting you to know every single unit there ever was, but these are, the most common types of units of measure that you would learn in a classroom, or to sort of understand these basic relationships. Time is actually one type of unit that we as humans can agree upon. Pretty much the entire Earth uses seconds, minutes, hours, days, and so forth, thankfully. But it wasn't always the case. And these sorts of measurements have not always been used by humans. There's been a lot of other historical types of measurement that humans have used. And then, so the other system, which this would all be the U.S. standard system, would be called the metric system. The metric system is another system which is much simpler, because one of the complexities of our system is that there's lots and lots of different types of things, and to remember them all is pretty hard unless you're very familiar with them, as most of us are, just having grown up in the United States. But the metric system is way simpler because all units of linear and two-dimensional and three-dimensional measure are all use the same units, meters. And then simply we adjust the prefix, like kilometers, millimeters, centimeters, to adjust the size. And the other benefit about the metric system is instead of this weird relationship where things are groups of 3 or groups of 12 or 16 or 4 or 8, it's all just scales of factors of 10. Like the difference between a millimeter and a centimeter is just 10 times the difference. And saying, the difference between a centimeter and a meter itself is actually 100 times. And the way you would know those differences is by the metric prefixes, which I put this table on your handout as well, so you can see a lot of the differences in them. But it's kind of all relational to the base unit, which is 10 to the 0 power, or essentially 1. Thinking about the scalar factor, if you're just talking about meters, 1 meter, that's like your baseline. And the relationship between a meter and a centimeter is 10 to the minus 2, or 1/100th, or 0.01. And the conversion factor would be, well, 1 meter is equal to 100 centimeters, or 1 centimeter is equal to 0.001 meters in terms of its relationship. So all of these numbers are the relationship of this amount to the base unit. So 1 centimeter is equal to 0.001 meters. Because a centimeter is very small. It's the thing you see on a ruler. And a meter is somewhere roughly around a yard. If you think about the length of a yardstick, if you took 100 centimeters and lined them up, that would make an entire meter. And things like kilometer is not exactly a mile, but it's in the ballpark of a mile, which stands for 100 meters. And those are, some of your more common, 1,000, not 100. A hectometer would be 100 meters, which is not very commonly used. I'd say hecto and decameters, those are very, very rare that you would see them. Same with deci, very, very uncommon prefixes, but they are what they are. And then, millimeters are another pretty common one, which would be 1,000th of a meter, which on a ruler, when you see your centimeters, a millimeter is the tenths. It's the division of the centimeter into tenths. So you could measure in millimeters for something that's very, very small. And then getting into smaller scale, you probably have heard of the term like microseconds or nanoseconds. Those are like fractions, 1/1,000,000th or 1/1000,000th of a second, just very, very small intervals. You could also have a micrometer or a nanometer, which just refer to very, very small units of measure. An angstrom is a specific type of unit which is measured. What we often measure in chemistry or with particles, just because of the scale of things that are very, very small. And then using like larger things, mega, giga, tera. You probably recognize these terms from bytes. Like megabyte stands for 1,000,000 bytes. A gigabyte is 1,000,000,000, and a terabyte is 1,000,000,000,000. And all of those, when it comes to storing data on a computer, modern computers can store tons of information compared to the byte, which is where the term byte comes from. This basically the individual unit of storage. But anyways, also I've included a conversion between some of your most common types of measure from the US system to the metric system, because the key, if you're staying within one system, it's very fractional, because all of the relationships are exactly 8 times larger or 4 times larger or 12 times larger, 12 to 1. And in the metric system, everything's very nice because everything's scaled by 10 or 100 or 1,000. But actually, if you go between the systems, then unfortunately there's not very good overlap, and there's kind of a approximation that needs to be taken into account. But let's look into a few examples. And dimensional analysis is a process of setting up fractions in order to convert one type of units to another. So let's say we wanted to convert 42 inches into yards. Well, you probably have your own technique for figuring this out too, but the way that, one of the more common ways is if we start with the unit that we have, we don't want to actually change the value of 42 inches. And often we'll use the abbreviation. So inches is abbreviated as IN. And if we multiply that by the idea of dimensional analysis, I want to always multiply by 1. I never want to actually change the value of the thing that I am working with. But what I'm going to always do is I'm going to multiply it by a fraction where the top and the bottom are equivalent values. But in this fraction, we're going to use different units, because essentially, like if we think about the relationship between an inch and a foot, there are 12 inches, and that's equal to 1 foot. And if I think about this fraction, it appears to be multiplying by 1/12, but in actuality, this is just multiplying by the same amount over the same amount. And the reason I set it up the way I do is because the units will cancel appropriately, assuming that I set it up correctly. Because if I have inches divided by inches, what will happen is those units, the meaning of that units will cancel out. And I'll convert this into a fraction or a fractional value that involves feet. So what I'd end up having here is 42 over 12 feet as my answer. And notice that I wouldn't say I'm done with this question yet, but if I was trying to convert 42 inches into feet, I would have this as my answer, and I could go about my business and actually, simplify the fraction, write it as a whole, like as a mixed number or whatever. But, we can actually continue the process of dimensional analysis by multiplying again, because my end goal is actually to get into yards, as this question states. And in the same exact way, I know the relationship between feet and yards. There are 3 feet and yards. And so again, I would want to put feet on the bottom and yards on top. Again, using one of the equivalencies in order to do this. Or again, you can call them, like another thing that they're often called conversion factors. Because it's like a proportion, basically. This is equal to this, and in scaling it the way we are, we're not changing the actual value of it. Because again, these are equivalent amounts. Essentially, we're multiplying by 1. And since we're taking the original amount, multiplying by 1 and by 1, it's not actually changing the value. It's just changing the units as we go. So what I end up with here is will be in yards, because again, I would have had 42 over 12 feet divided by 3, which will put it into yards. And obviously you could just think about this more relationally, but for more complex conversions, it's helpful to think about it as more of a algebraic or an arithmetic statement. Anyways, what we'd end up here with is 42 divided by 36, because the rules for fractions: multiply a whole number, we could put this over 1, and all the numerators will multiply, all the denominators will multiply. So we'd have 42 times 1 times 1, and we'd have 1 times 12 times 3, which would be 42 over 36. And again, this would be in yards. So it's kind of like I can continue processing my number through various conversion facts that I know until I get to the desired goal. And of course, we'd want to simplify. This would be reducible by 6, which would leave me with 7 over 6 yards. Or again, I could convert this to a mixed number. That would be 1 1/6 yards, or even as a decimal, approximately 1.16 repeating, or exactly 1.16 repeating. So approximately 1.167 or whatever. Again, you can round it off, leave it exact. Again, it just depends on how, who's, what form you want it to be answered in. But, I'm assuming that you guys are all on top of your various types of numbers at this point in time, to get a way of representing this using yards. And again, the idea is, well, now I can imagine what this means. If I think about 42 inches, well, ruler is 12 inches, so I could think there's many rulers there in a line. Or if I know, what is a ballpark of a yard, that's a little bit easier to imagine. It's a little more than a yard in terms of what this means. In the next video, we'll continue talking about volume and other conversions. We'll just keep right on going.